So thank you all. Thank you for the EPA for inviting me. My name is Brian Coghlan. I'm the research officer for the National Barrier Programme. And first off, I'd like to thank the Department of Housing for funding the programme and all the help that I've received from my regional colleagues in IFI for actually facilitating these assessments that I will go on to talk about in a second. So I'll hang my hat initially. Free rivers work better, and that's the general scientific advice that's coming out for across Europe and the world. They just, hydromorphology is better. There's fish passage. They're just a more stable functioning system, more resilient and more resistant. So what I'm going to talk about is barrier effects, the fish species, the drivers for change, the barrier types, assessment in Ireland, mitigation strategies, and into the future. So here's a hypothetical diagram of a natural river on top and a dammed river at the bottom. But you can replace dam with culvert, weir, any man-made structure in the channel. As you can see on the top, you have a natural turbid flow environment, spawning habitat, natural temperature regimes, natural fish population, natural invert population, and these populations would then go on to be score highly for the Water Framework Directive, and that's where it would fit in. But conversely, in the bottom image, you can see where you have a dammed river. And the dam changes an awful lot of things, and that's why I'm in the hydromorphology section, because it has the potential to turn a river into a lake, so utterly change it. So you have, all of a sudden, if you've turned a river into a lake, you've got uniform flows, you've got mass sedimentation, you can change the fish habitat, you can change the fish species composition and the invert composition and the whole thing, and all of a sudden you're not meeting your WFD requirements. You also have an altered temperature regime. You've got a lake in the river, so that can heat up in the summers. We're now into a climate crisis, so we'll have less water, more temperature. That again will affect the fish composition. And the dam itself, it's a fish passage obstacle. It can stop the free movement of fish, inverts, all these aquatic organisms from going upstream. And it's a hazard, but also, conversely, it's a public benefit. So people use these structures for water, electricity, amenity. People see them in their landscape all the time, and they recognize them as something, that's always been there. So, changing these things is not a simple thing. So if we talk about the species that are involved, we have our iconic salmon, sea trout. We're moving from sea to fresh water. But we also have other species there that do need to move in terms of their life cycles, and we don't really think about. So pike, bream, brook lamprey, brown trout, they all need to move around, and they have to go to their spawning grounds, they need to go to their nursery grounds. And if you look at the Irish environment or across Europe, where it's actually worse, there's all these structures in the river that will prevent them getting to where they need to go when they need to be there. And that can have a detrimental effect on populations as a whole. So implications. Things might not get to where they need to be when they need to be there. It's very simple. You can find upstream some structures, populations become extinct. But you all have more insidious problems in terms of you have multiple barriers in a sequence. And if a salmon population has to transverse 6 or 7 structures in a row, you might find by the time they get to the top of a catchment, not enough fish get there to actually hold a viable population. Exposure to predators, loss of energy. They can spend hours, days, weeks trying to get over a structure. Then loss of eggs and milt, habitat loss, and again, impact on hydromorphological processes. Downstream of some of these structures, you don't find spawning habitat for salmon or sea trout or sea lamprey. All the sediment that's progressing naturally down the channel can be captured in the impounded sections. So you have loss of habitat, you have a loss of spawning habitat. In the bottom right there, you can see that's an adult salmon that has spawned the year before, trapped above a weir. So that salmon there has a fungus infection. And the only way he's going to clear that is if he gets to the sea. But he can't, because there's a weir in the way, and he's unsure about transversing downstream over it. So our drivers for change, we talked about the Water Framework Directive. Continuity of the river is not disturbed in terms of can things get from one end to the other. That's also aquatic organisms, but also sediment transport. We have the Habitats Directive. specifically for salmon, shad, and lamprey. The shad there is the one above the lamprey, the silver one, this guy here. Nobody really thinks about him, and he's quite poor in terms of getting over structures. He's in our lower estuaries and our lower rivers. Eel regulations, and we have to be thinking about the EU biodiversity strategy for 2030, where at least 25,000 kilometres of river have to be restored to a free-flowing state by 2030. So we need to start thinking about this now. And we have when we talk about the types of barriers, these are all structures that we see around Ireland. A lot of different things. All of those structures there impinge on fish passage or the free movement of sediment. They interrupt natural hydromorphological processes. But as you can see here, there's a lot of different types of structures. So when we started the National Barrier Programme, we sat down and we said, okay, we need to think about how do we kind of classify these things. Can we classify them into different groups and make it easier when we go out there to assess them to have them into different categories? So what we did is we have our natural structures, sort of waterfalls, natural rock outcroppings, and they do impact on fish passage, and they do impact on sediment movement through a system. But they're natural physical form of the river, and they're WFD compliant. And actually to do something with them, to make them more passable, would actually be breaching the WFD, because you could maybe allowing species upstream where they haven't been before. On the other side of the things, you have the artificial or man-made structures, and we broke down the whole list of structures into 5. So we've got dams, culverts, weirs, fords, and sluices. For dams, thankfully we don't have very many of these in the country. Usually they raise the water level, forming a reservoir, and they usually generate electricity or a supply of water. We have culverts, and these are the ones that you will find mostly around the country. These are 95% of the structures that are barriers to fish passage. So you can see here, this is the bridge in the Field, this is the bridge in Wicklow. The example there is how it happens. People think, no one puts in a bridge to have a big drop off it because it causes engineering issues. But if you put in the wrong culvert in the wrong place, the wrong shape, that's what happens. The river will naturally erode around the structure, and it'll create a drop out of the structure. So it wasn't done deliberately, just rivers change over time. Here's another example of a culvert. This is what happens when if you see the image on the bottom right, if it's inappropriately sized, you can see a fish there trying to make passage on the structure, and he just gets blown off because it's too shallow and too fast. So these are the things that prevent fish migrating through culverts, be it the drop or be it the way the velocity of water coming through. We have weirs. The big picture is the Shannon. In the middle of that structure there, you can see there's a small square bit. That's the fish pass. So in current thinking, that would be inappropriately sized, but that was built over 100 years ago. So it was a long time ago. More example of weirs and examples of what's happening to them. So a lot of these structures over 100 years old, they're starting to fall apart. We need to talk about management. We need to see what we do with them. So that's another conversation. We have fords crossing the river for cars or vehicles, and we have sluices, which are part of major sort of navigation structures in Ireland, where most of them are. So the water, you can raise and lower water levels. So, do you understand the effect of a barrier? You do have to think like a fish, because that's who we're trying to deliver a product for. And you've got to understand their limitations, because everybody thinks about those guys in the bottom left, the salmon, and they think how big they can jump and how high they can jump. And they are amazing creatures, but you've also got to think about the lamprey and the shad, the bream and the eel, and how they're going to get over structures. Because when you think about it, when you look at it and you look at their capacities, when does it become a barrier? Well, it becomes a barrier to fish passage in terms of lamprey or shad or salmon smolts at 0.1 of a metre. That's not very big. It's starting to impact their ability to migrate at that. If the water level is less than 0.1, it's starting to affect their ability to migrate. If the effective length of the structure is over 10 metres and it's fast flowing and turbulent, that's also affecting their ability to migrate. So, in terms of, it doesn't take much to have a big effect on a population and potentially sort of create a situation where it may not be viable in the long term. So, any problems here for fish when you're thinking like a fish? This is a fish pass on the Kells Blackwater. High energy, high velocity, high turbulence, high flows, Well, if you're an adult salmon, yeah, you're grand. What about everybody else? And this has been pointed out in the literature, is that a lot of these fish passes, or fish passage options, were designed for adult salmon, but don't take into account everybody else. Any problems here for fish? This is a culvert from the Midlands. This is like your average fish passage problem that you'll find in culverts. Well, the fish has to jump onto the culvert first, and then he has to swim through a skim of water to get to the other side. So nobody's making passage over that until the floodwaters come up. And maybe even in that situation, the velocity through that culvert could be so much that they can't. So like these structures can and do sort of affect fish populations at a national extent. So our mitigation strategies, well, we have documents, we have stuff that we're working on in terms of making sure that no more damage is done, or we can rectify the situation. We have that. OPW produced a recent document on fish passage guidelines. Mark Radiker was involved. It's a good document, but it only looks at small culvert-type structures. And there's some more work there done for IFI in terms of guidelines. But for the large structures, they're really case-by-case basis. So when the Bachelor Barrier Programme started in 2008, we had to ask ourselves, do we have a problem? Like, how much is out there? What are we going to do about it? How do we go about it? So we created a national database, and we went around and we pestered all these organizations until they handed over their goods. And you see the CFRAMs were there. It's a great source of information. Iarnród Éireann, TII, OPW, Ordnance Survey Ireland. And we created a national database, and we hosted it in the cloud in Agal. And then we created a little phone application where you can directly assess the structures you're looking at, and you assess it in the field, and it's paperless. So it was a great tool because it allowed us to sort of offload this work to our regional operatives, IFI fisheries officers in the field, to get them to do these assessments. And it's worked out really well. But if we look at the national database and what we have, well, it turns out that culverts are our big problem in terms of road crossing structures. There's more of them than anything else. And yeah, the big ticket item is that there's 73,000 potential barriers out there in terms of potential problems that might be out there causing a problem. And weirs are only a small problem compared to all the culverts. And when you drill into it and you look at it across Europe, the culverts have been identified as potentially being the big ticket item that we need to sort of start grinding away out. So where are we now? Well, after 4 years, we've done about 34% of the potential barriers in the country. We've classified almost 20,000 structures as not a barrier to fish passage, which is a win, but found about just over 6,000 structures that are a barrier to fish passage. So there's a lot of problems out there. Some of those structures would be on very small streams that wouldn't be cost-benefit to actually do something about, but some of them are, would be very much a worthwhile endeavour to mitigate the fish passage. And we did some number crunching, and we looked at what we have, and we reckon a grand total of probably about 10,000 barriers to fish passage in the country, but some of those are on actually very small streams. So watch this space. We'll have, as we collect more and more data, we'll be able to tell you, we'll be able to go into it a bit more than that and have a proper figure. And then people start talking about mitigations. And in the real world, I love this slide. I can't remember who I stole it off, but it's brilliant. Because in the middle of that square there, that's where fish passage is. But it has to operate inside sort of the larger economic, historical, social, and legal elements of a society. So it's all well and good as a scientist come along and saying, that structure there, that needs to come out, that needs to be mitigated. We need to improve fish passage on that structure. It has to be around the rest of that. And and all the other bits and pieces that come to it in terms of getting the job done. So preferred examples of mitigations that we could do out there: remove the structure, brilliant, problem solved. It's gone. There's an example in Tipperary of a bad bridge floor. Just remove it, replace it with a free, sort of a spanning bridge. Your problem is gone. No fish passage issues. We could breach the weir, cut a chunk out of it, and just have the river naturally flow through. Keep this historical bit on one side. It's good. Or you could create a rock ramp, which is sort of like
where we're going now in terms of a fish passage option where you build a series of steps up to the structure, be it either of a culvert or a weir, and you build a series of steps and you basically allow fish pass to go that way. You can also create, obviously, put in technical fish pass solutions. You can create bypass channels, and you can create other things to improve fish passage. But they're the three ones that I like the most, so I'm only going to show them to you selfishly. And then again, this warning of lack of management. In a lot of these cases, something has to be done because they do fall down over time, and then everyone is upset. But they do fall down progressively. As you can see in the bottom left picture there, big chunk of the weir has fallen out on the fish pass. That fish pass is no longer functioning, so it's no good anymore. One section in the bottom middle on the Boyne, big chunk of the weir has fallen down. The water that's going through the sort of the broken section of weir there is no longer going down the fish pass. So it's reducing the efficiency of the fish passage option. So these things you have to be mindful of. And then this weir here, this salmon fish passage option here, the baffle is broken. So it's actually of no use at all. So they need to be managed. So over the last 4 years, the National Barrier Programme, we've got a national database, lots of structures, created an application to assess them. And we've assessed 25,000 structures, identified 6,000 potential barriers. But we've also been investigating, in terms of if we do mitigation, if we do put in a rock ramp, how do we rate that against climate change in terms of change in flow patterns, change in temperature regimes? Can we put a rock ramp in now and say, that's grand, but in 20 years' time, temperature is too high, not enough water. Is it sustainable for fish populations? And we are in Ireland. It's all about the salmon populations a lot of the time. A lot of the situations. I'm not saying that's right, but salmonids, they're cold water species. They don't like warm water. Can we afford to have a situation where you've got an artificial lake in your middle of your river where your average temperature is well up into the 20s, and the salmonids can't survive or can't function in that? So it's something we need to be mindful of. And then the take-home message. There's a lot of people out there, state bodies, who have these structures. They just have to be mindful of, that they do have an impact on fish passage and hydromorphology, and the knock-on effects of Water Framework Directive. So, I think IFI will be having conversations with county councils and bridge owners about how we can mitigate these structures and maybe make fish passage better and improve WFD status. So, thank you very much.